Okay, so for next year, whatever one-pagers you have from this year or last year, just take them out of your out of your notebook and put them in your new notebook. And then you've got all this work. You might want to keep it because you might want to refer to it again, but at least keep the one-pagers in your calculus notebook. I'm going to do stuff the same way. You're going to still post assignments like you would with pictures next year, assuming everybody will still be in class, but I'm not going to scan them like I did the year before. So we're going to keep going with that. That means you can have whatever notebook you want. It can be spiral, it can be free wing, it doesn't matter as long as you have some sort of pocket to keep stuff that's not already, spiral in your thing. So this you already have, include all one-pagers for functions, just so you can look back and go, oops, I forgot. I told you calculus is going to mix everything up, so if you can have an easy reference, that would be nice. Khan Academy, there's a new thing that they started this year. It's a course called Get Ready for Calculus. It just covers some basic stuff. I'm going to assign that soon. You'll want to do that whenever before the end of, the summer, before we come back to school. So get ready for calculus. It's not differentiated between AB and BC. So if there are topics that you're having a lot of trouble with, you can just email me and go, hey, Ms. Haight, is this something that I should look further into? And if so, I'll let you know and give you some guidance about things like series and sequences that BC will have to do. So that will be posted soon. It's not posted yet, but I'll post it before the 15th of July. You could be working on that anytime during the summer. And then the 15th, your summer work has these things. So there's 5 circuits on review material. There are circuits because you're at this point where I need to make sure you know these things, but a circuit will let you check your answers and know that you're good, okay? It's just a matter of these topics. I need to make sure you're ready to go so we can start with the calculus. So there'll all be review material. What? It's usually posted July 15th. There's a driving log activity, which I might go ahead and post for you if you wanted to print and do. The driving log activity is you going anywhere for, I think it's 2 hours, and keeping a log. So you're not driving, somebody else is driving, and you're going, okay, we're starting. So I'm going 0 miles per hour, and here's my odometer reading. Does everyone know what an odometer is? Okay, it tells you how many miles your car has gone. So if you're at 30,000 miles when you start your trip, in 2 hours, you're going to be like 30,000 plus 120 miles or something, like that. So I asked that because some people tried to just fill in their own chart last year, and I was like, this is not a trip. This makes absolutely no sense, and you don't know what an odometer is. So I don't want to call you out on that next year. I would like for you to actually write down stuff. If you only go for an hour and then some other time you go for a different hour, sure, put those together on one driving log. Obviously, please don't do it while you're driving. Every 5 minutes, you're going to write down how fast you're going. So we start at 0, we're going 45, we go to Chick-fil-A and get breakfast. Before we go on our trip, we're back to 0, then we go 70. It's fine. It doesn't matter what it looks like. Okay, it's just whatever happens after 5 minutes. If you're stuck in the Chick-fil-A line for 5 minutes and you're still at 0 miles per hour and 0 miles per hour, that's fine. Okay? So you're just keeping a log of it because that's going to be one of the things that we start the year off talking about rates and distance, all that kind of stuff. But you having driven in a car and having actual data to look at will make some of these things make sense. They just won't be like big ideas in the cloud. You'll be like concrete stuff you can make sense out of. All right, so driving log. Please actually do that. Again, I had some sketchy ones this year. Excerpt from a book. I'm going to give that to you today. So this is the introduction to this book. We're not reading this book next year, but it is a book that talks about calculus in everyday life. And this introduction talks about some of the big ideas, and we'll introduce some stuff to you. So part of your summer reading is reading this excerpt. It's just this big. It's 10 pages. And then you have some questions to answer. But I'm going to give this to you because I can't post it like I can post the circuits because it's a book. I can give you an excerpt from it, but I'm not going to post it anywhere. I'm not going to break any laws that way. So I'm going to give that to you now. It says now here. Then BC people are going to have a preliminary study of parametrics, which we didn't get to this year, and a little bit on series and sequence. Just an introduction like we did with polar, so that some of the terms are familiar when we really get into them during the year. So AB has these three things, and Khan Academy, BC has a little bit more, and Khan Academy. Questions about what I need for you for calculus for next year? All right. Your essay question, because you know the exam has an essay. Your essay is very short because you have that page, like your review summary that we did. So you have a lot of open-ended questions that aren't multiple choice. That's the main part of that page. But you also have two very short answer questions that have the ideas about periodic functions. So by periodic, I mean it's going to be sine or cosine, probably. That's the most commonly used. Can you talk about what it means to go on forever, right? So to repeat up and down, that means that it has an infinite number of maximum points, right? An infinite number of minimum points, an infinite number of zeros, because it crosses over and over again. Periodic function. Can you discuss that and talk about it in terms of math? I kind of went over that with the review sheet already, because I put down, I don't know, I don't think I have my filled out ones. I think when we did solutions right here for cosine, we said where it was 0, and then we put plus k pi on there kind of thing. Can you tell what k pi means? That kind of thing. Also, thinking about limits with going to infinity. Those ideas would be it's a little tiny short. I don't give you much space, so I really don't need a whole lot. Just kind of complete the idea of periodic functions. Yes? Good? All right. The rest of your test is multiple choice. Yes? That kind of question. Okay. Here is an example. This is not Hutch's. It's an extra printed one of what it looks like. Yes, 300 questions. No. It says 49 questions. Oh, I thought you said 300. You're far away. Anyway, so notice that this last group of ones looks different because that's a matching thing. So all of these are regular multiple choice, and then there's a group that looks a little bit different on purpose so that you go, oh, these are the different ones. So this is a matching one. You wouldn't have mathings, pictures and graphs and functions. Yeah. So, I mean, this is going to be a breeze. But anyway, I just wanted to show you that it looked different so that when you got your exam, that didn't freak you out any. The exam is this on the front page. If you take it off, just ask whoever's helping you with the exam to staple it back on there so I can keep them together. The very last page, so this would go on the front. The last page is your fill in the chart and essay questions, and it's on the back. So I only have to grade this side and the back. Please don't put this on the back. You ruin all my feng shui with how I'm going to grade the exams. Make sense? All right. Okay, so we have an example of some stuff written down. I see lots of good stuff for linear, so this is a video. Y'all can all go back and look at it. I see regular equation. I see point slope equation, which is lovely. Vertical, x equals. Horizontal, y equals. Good basic stuff so you don't get those things confused. Odd and even. So leading coefficient or leading coefficient negative. Different Saturday Night Fever going on. You've got a notation for middle behavior. Would that be zeros? Okay. So this is in behavior. And then middle behavior, I might add zeros here if I was going to put that on there. Even degree is either up with a positive leading coefficient or down with a negative leading coefficient. Quadratic function, we've got, and again, you can just pull up this video and pause it and see all this stuff if you want. But we've got degree 2, axis of symmetry, negative b over 2a. That's also where you get the minimum or maximum. That's the x equals. Yep. Maybe. Oh yeah. Here you go, Emma. So solving any quadratic with negative b plus or minus square root of b squared minus 4ac all over 2a. Vertex form, one of my favorites. But this negative b over 2a, that would be like the thing that I often forget. And I'm like, there's an easy way to do this. Don't forget that, and I'm not going to write on this one, but if you know the quadratic formula, the negative b over 2a is right here in the front. So you can sort of see it in the quadratic formula there. It will help you find that. So that x equals negative b over 2a is both the axis of symmetry where you would fold it and it would be the same, or it's where the vertex lies. It's the x value where the vertex lies. So if you find that x value, you can plug it in, and you'll know whether you have a minimum value, if it's a positive parabola, or a maximum value if it's a negative parabola. It'll tell you about that. So this is a really handy thing, but it only works for quadratics. And then you might want on here, for those of you who are not sure where a, b, and c comes from, is to write down the ax squared plus bx plus c. Because you need to have it in the right order, or you can't arbitrarily pick which one's a, b, and c. They have to be in the right order. Radical functions, this is what the square root looks like. This is the shift. This is the cube root. So they have different looks to them because the square root function has a limited domain, but they shift the same way. So rational function, we might want to go over those rules. We can do that. Exponential function and logarithmic, they're together because, so these guys are together because they're inverses. These guys are together because they're inverses. Yeah, it's fine. This is your study guide. You have until Friday to take your exam, but the idea is that in a minute we might grab somebody else's. Maybe they have some things filled in here. So exponential function also has shift. Logarithm has shift. This graph goes through this point and goes this way. They're inverses. All kind of good stuff. We have stuff on the back. We have a little bit of stuff. Oh, that's what I just wrote down. So thank you. Anybody else got some good stuff that we don't have, that we should have? Rational functions. Do you remember what the rules are? Don't all speak at once. It's so hard to hear you. That was a joke. Okay, so rational means we have a polynomial on the top and a polynomial on the bottom. When we talk about middle behavior, we're talking about vertical asymptotes. Where do vertical asymptotes come from? So is the denominator equal to 0? Denominator. See, that it's not look like a word. So they come from the denominator equal to 0. Unless they cancel out, and that would be a whole, right? So we could add that unless they cancel. It's up to you. And then, so that's middle behavior. And then you have horizontal or slant. And where do they come from? Well, it's a good thing we're going over this stuff. So horizontal or slant asymptotes come from what's happening in behavior. So they're talking about as x goes to infinity or negative infinity, which grows faster? Or do they grow the same? Numerator, denominator? So y equals coefficient over coefficient. Can I write it like that? For the same degree. If it's x squared over x squared, they grow at the same rate. So it's whatever goes in front of the x squared. We can probably find a place to put an example on here. You can also have, so that's 1. 2, you can have y equals 0 if the denominator has a greater degree. Denominator greater than numerator. And that's degree. So there's my little note for that. And there's one other, the slant one. Where does that come from? Comes from long division. It's because the top one grows bigger than or faster than the bottom one. So the top one has to have a degree up by 1. So degree greater on numerator. Long division. This doesn't really fit in here. Y equals mx plus b. Maybe this is just a hint of things that, since y'all were very silent here, that you need to go back and look at that chapter, which I feel like is chapter 5. Nope, 4. Chapter 4. Sine and cosine, you've got this looked like one word there. Sine. There we go. Okay, plus or minus a sine and then b of x minus c plus k. So plus or minus is flip. A is amplitude. B is the period change. C is phase shift, which means left or right. And K is up-down shift. So that would be a good thing to look at. I know you know what sine and cosine look like, so I haven't graphed that here. You might want to think about domain being all real numbers for sine and cosine, the range being usually -1 to 1 unless shifted. But the idea that the range is limited. That's the word. Remembering that period equals 2 pi over b, because this is opposite math. It's inside the parentheses. So if it says 2 times, it doesn't mean it's 2 times as wide the period. It means it's going around the circle 2 times as fast, which makes the period shorter. You get the whole thing twice as fast. So it's opposite math. You take the normal period and divide by b because it's opposite math. Tangent and cotangent, you want to think of those maybe as tangent of x equals sine over cosine, while cotangent of x equals cosine over sine. And then their graphs, some colors. So their graphs look like this, and we did review these on that sheet. We have x equals pi over 2 plus k pi for the asymptotes for tangent. And then cotangent has different asymptotes, and it goes the opposite way. So they happen when sine is 0, and sine is 0 at 0 and pi. So pi plus k pi are the asymptotes. You might also want to, within these, think about triangles, right? So you could go triangle, here's an angle, and talk about opposite, adjacent, hypotenuse, those ideas. You might want to revisit those things so you could talk about that. Secant and cosecant, what was special about those graphs? What did we use to graph them? So it's like a parabola. It happens between the asymptotes, but the really simple way to graph it is if you graph cosine, if secant goes with cosine, this is what cosine looks like. And so secant was a u opposite all of these values. And wherever it was 0, we had an asymptote. So it's easy to find the zeros for cosine this way, and it's not available for the reciprocal function. Yes?
Well, we need to know, like, the log sines.
I don't, it's all non-calculator, so I don't have that on there. So secant looks like that. It has asymptotes where cosine equals 0 and cosine equals 0 at pi over 2. So x equals pi over 2 plus k pi. And then the other graph is what sine looks like. So sine goes like this. So it has u's, an up u and a down u in different places. But it essentially looks the same just because it goes off of functions that do look the same. So sine and cosine look the same. They're just shifted. Whoops, sorry. Secant and cosecant also look the same, but they're shifted. So this would be, yeah, pi. How about other things? Do I have unit circle in here? Ooh, I do. Let's stick with this for a second. Unit circle and trig ratios. So I started this on the other one. Opposite, adjacent, hypotenuse. Tell me about everything on the unit circle. Obviously, you need to know the unit circle, so you need to know what pi over 6, pi over 4, pi over 3 is. But any point on the unit circle, even if I pick this point, whatever it is, what's special about it? It would have a reference angle. It would have whatever this is, reference angle. But what's cool about every point on the unit circle is that you can, with that angle, you can make a triangle that's a right triangle. Every point on the unit circle satisfies x squared plus y squared equals 1 squared because it is a unit circle. So if I told you that x equals 1/10, that would be gross. But 1/10, you could find out what y is because it would have to be 1/10 squared plus y squared equals 1. That actually wouldn't be that bad. So if I did that, it would be 1/10 squared plus y squared equals 1. So let's see. We could do that math. That would be 1/100th plus y squared equals 1. Y squared equals, are you okay if I just write 100 over 100 right here? So then you'd subtract 1/100th from this, then you'd get 99 over 100. That's not really that hard to do. And you take the square root of it. So y would be either plus or minus the square root of 99 over 10. That wasn't that hard, right? And then you would know whether it's plus or minus because we would tell you what quadrant it's in. So let's say that this was in quadrant 4. What would the y value be? It would be 1/10 for x, and then y would be which one? The negative one. Okay, so everything on the unit circle satisfies the Pythagorean theorem. We only learned 3 of them. We only learned pi over 6, pi over 4, and pi over 3. And then they repeat in each quadrant, so they have different values depending on where they are, and the pluses or minuses. But all of them satisfy it. We just know about 3, right? And then you should study your unit circle. That's probably too hard to put in this box. The unit circle should have been the essay. Yeah, there's a limit to what I can do, and you had to know the unit circle to do some of the mins and maxes, so that's where I left it. Polar, rectangular to polar, I really have that on the other side. I don't know why I have it twice. I guess I just didn't want to forget it. So this kind of thing, x squared plus y squared equals r squared, would be very straightforward, non-calculator types of problems where you could find points from one to the other. Okay, so anything that I would give you here would be something that you would know. Theta, if it's pi over 6, you could find sine of pi over 6. I'm not going to give you some weird number that you need a calculator for because you're not using a calculator. Synthetic division and long division. We practice long division. I'm on the second side here. We practice long division. I feel like recently, but maybe that was in Algebra 2. Does anybody need to see synthetic or the other? You're saying no, but I don't believe you. Let's say that p of x equals 2x to the fourth plus x minus 7. And I want to know p of 3. And pretend that I asked you to do it with synthetic division and was going to check how you did it. You don't have to do synthetic division, do you? What could you do here? You could just plug in 3, right? But I want to show you synthetic division, so let's see it. Reminder, we put a 3 in the box, and then we put 2, 0, 0, 1, negative 7. Because I need each place. Remember this a little bit? Okay, then what? Okay, so we're going to multiply and get 6, add 18. So 3 times 18, 54. Is that right? Oh, and 3 times 54, that's no fun, but I'm going to guess 162. What? Oh, yeah. Thank you. So, good to find my mistakes. I was already thinking I had to multiply things, and I did it in the wrong place. Add down. 18 goes here. Now multiply 54. That's 55. So, that's 150 plus 15, 165. So, minus 7, 158. So 158. The remainder is the same. Is this value 3 a 0? No. If we got 0 out, it would be a 0. This one's not. So that's what synthetic division looks like. Long division, anybody need that? You need to do long division if you're looking for the y equals mx plus b slant asymptotes. Okay. I'm going to mark this out because I have polar on the other page and do long division. So if I said y equals 2x to the fourth plus 3x plus 7, and on the bottom I have x cubed minus 1. So I'm going to do long division. I'm going to do long division y. The degree is bigger by 1 on the top. This will tell me the slant asymptote. It does have a vertical asymptote. What would that be? You can just set this equal to 0. Throw the 1 on the other side. Take the cube root. It's x equals, what makes it 0 on the bottom? 1. Okay, so that one was easy. But the other one, we need to do long division. 2x to the fourth. I'm also going to leave blanks. I don't have to go very far, though. All I need is y equals mx plus b. So we first divide here. X cubed goes 2x. Multiply it back out. 2x to the fourth minus 2x. I'm going to put it way over there. Change the signs, right? Change the signs. That gives me, that cancels, and I have 3x plus 2x is 5x plus 7. Does x cubed go into 5x? No. So this is the remainder, and I don't care about the remainder. Why not? It is so insignificant that we don't bother with it. What happens to this when x gets really large? It's really small. Can you see it? This actually is an asymptote. What happens with it? It goes to different rule. This goes to 0, right? It has a bigger denominator. So we don't care about this as we go to infinity. It's going to be y equals 2x is the slant asymptote. There we go. Now let's print it up there. So we don't care about that. That covers that other rule. So as the denominator is bigger than the numerator, it goes to 0. We can just disregard it. If we had had like plus 5, we would have kept it in here. But this one didn't have a plus 5. So that's our slant asymptote there. Limits, we've done a lot with those. You might look through the circuit that we did. They're going to be pretty straightforward. We had 3 ways that we could find them. What are they? Substitute, factor, or some other means to just do math on it. So just like either multiply or whatever, you're just going to do something mathematical to it that simplifies. We had that on the circuit. But factor's the number one, because if you cancel it and it's a whole, then you can just go substitute in. So it's usually factor, but sometimes you have to do other stuff. And then the third way was, rationalize. So you multiply by the conjugate, which has the same numbers, just the opposite sign. And then you substitute. So substitute, like, that still happens. Even if you do 2 and 3, you go back and you substitute. And our limits look like this. The limit only exists when the limit as x approaches something from the left equals the limit as x approaches something from the right. So left has to equal the right. Limits? Sure. We cover limits. We actually spent some time on limits. Yep. It's the preliminary stuff to calculus. This isn't the entire whole limits chapter. This is the preliminary stuff, yeah? Say louder. I tried really hard to think about all the different things that I had and put it on this, yes. I mean, this covers our main functions. We did the function review. I mean, I didn't go through and like do this side by side, but I tried to, yeah, make it condensed. Okay, so we had pictures finishing off limits. If we had this picture, that's supposed to be a hole. Do we have a limit everywhere? We have a limit everywhere, including the hole, because we can approach it, but Mr. Waffles doesn't exist, so even this place has a limit. If we did this one, does it have a limit everywhere? So this one doesn't have one right here, no, but it has one everywhere else. You need to read the couple questions I have and make sure that don't assume that I'm asking about this spot. I could be asking about over here. X equals -2. Does it have a limit? Sure it does. Well, it would be look at the graph, tell me what it is, and it would be whatever value this is. So 3, I don't know, I'm just making it up. But like this was on the practice worksheet that we did, the summary function 2. I had some limits. Mainly you just plugged them in and they worked. I graphed them. You don't have to graph your functions for that. You can, but it's not required. I'm not grading the graph. But if you want to try to sketch it so you can look at it, I find that to be helpful, but it's not required. So in my mind, I would have looked at pictures to see stuff. What about this limit that does not exist? Why doesn't that exist? because we don't know what it is. An infinity. This would be an infinity one. As x goes to infinity, it does not exist. We call that oscillating, but you can say it does not exist. Things, so you're asking about things that I don't have on here. Let's see. Ooh, I just had it in my head. Okay, so domain and range, right? I don't have that explicitly written out like I've got asymptotes versus wholes. Wholes would cancel. This is I'm just going to do this while I'm here. Denominator equals 0 or in behavior. Those are the two kind of asymptotes we have. But define them. They're like boundaries of the function. Boundaries of the function. Okay, so I don't have things on here like domain and range, but we've talked a lot about domain and range. So if I give you a rational function, I need you to tell me that the domain does not include the things that make the denominator 0. If I give you a square root function, I need for domain you to tell me that it can't be things that make it negative, right? So those are kind of included on the summary review sheet, but I don't have them on here explicitly, domain and range. Yes. Can I do a log graph or some log? Okay, so logs. Yeah. Okay, so all right, yep. Oh, you're not. Okay. So we have log questions. Let's say that we have log of x plus 2 plus log of x equals 2. This is an equation. The question would say, please solve this. And there are 3 kinds of log equations to solve. There's one where you have log base whatever equals 3, and you need to write it as 10 cubed equals x, right? Oops, you can't see that. Make it smaller. So this is write it as an exponential. You have a log, you can write it as an exponential. This is easy to solve. This one, we're going to do that, but not yet. Because we have 2 logs, we're going to have to combine them. The second kind that you have is where you have log base 4 of x plus 3 equals log base 4 of 2x. And what do you do there? Yeah, you drop the log base 4 and you solve for the arguments. So you would just say x plus 3 equals 2x. I feel like there's one more kind, but it's lost me. Maybe it's just this one that's separated. So going back to this one's more complicated than this ready to go, number 1. What base does this have? It has a 10. So you probably shouldn't be lazy mathematician. You probably should just include that if you don't see it so you can see it. And in order to get the left-hand side is 1 logarithm, what's the rule? Yeah, so it's going to be log base 10 of x squared plus 2x equals 2. So now it's 1 log equals an exponent. Logarithms are exponents. So 2 is an exponent. It's an exponent for what base? 10. So it's going to be 10 squared equals x squared plus 2x. So we're rewriting it as an exponential here. Rewrite exponential. And now we'd say 100 equals x squared plus 2x. 0 equals x squared plus 2x minus 100. I just randomly made this up, so I don't know that 100 factors that subtracts and makes 2. Doubtful. So what would you have to do? Quadratic formula. Okay, I'm not giving you quadratic formula, but you totally could. Negative b plus or minus square root b squared minus 4ac over 2a. But this is log rules. These are exponents. So when you see a plus with exponents, that really means you have x squared x to the 2 plus 3. That's the same as x squared times x cubed. The 2 plus the 3 indicates multiplication, so we went to multiplication, and I multiplied x times x plus 2 and got x squared plus 2x. Is that better? So make sure that you say this to yourself. This is the base, and logs are exponents. That will help you put the 2 in the right place. When you get answers, make sure also that you only put positive numbers in the argument, right? The argument can't be log base 10 of negative 1 because that graph doesn't exist there. The log graph looks like this. There are no negative numbers. Goes back to domain. As you look through stuff, if there are other questions that you come across, shoot me an email. I'll be here during exams. Come find me, ask me some questions. Y'all should compare your overview sheets to each other's and just see if there's something like this, very small negative b over 2a that somebody remembered that you didn't, that you're like, oh, I'd love to have that, and just add it to your kind of notes. All right, that's what I've got.